Okay. Today the internet was very, very bad on my office computer. I don't know if it's a software issue or hardware issue, but I'm just trying to rework things out. Basically, in the second week of this class, we're trying to learn chapter 2, that is equation of value and yield. If you have already finished the chapter 1, you probably had seen some calculation of present value and future value. So now chapter 2, we are looking at in chapter 2, we're looking at equation values. So it doesn't have to be at time 0 or time 2. It could be anywhere along the timeline. You can set up an equation value at that time spot. Um, 2.2 is when you have a single cash flow and you have a effective interest rate of I, and this is the amount function for time t. By t, we mean capital T. So we have a couple of examples where you either have a cash flow that's unknown or the interest rate that's unknown. For example, this example, the principal is unknown. The future value is given, the interest rate is given, the time is 5. The present value, which we are using letter C, is not given. So we're discounting the 3,673.32 to the present time, and that's how we calculate C. And the second example, we have a time t that's unknown. So you set up equation value, which is future value equal to present value time the accumulation function. And that's how we get this t solved. In this question, we're trying to find the doubling time, and t will be how much time it takes for the money to double. And this is something that's called the rule of 72, because logarithm 2 times I divided by logarithm 1 plus I has a very close value, close to 0.72. So we can actually quickly calculating t by 0.72 divided by I. For example, if I equal to 3%, then 72% divided by 3% is 24. That means it takes us 24 years to double the money. So the rule of 72 give us a quick way to calculating the doubling time, but then you can also set up the time value equation to solve for t. Um, this example after that is how do we calculate interest rate? If you only have a one cash flow along the timeline, so you have a future value, a present value, the calculation for I is just a solution for a exponential equation. So we solve for the I, that will be it. When you have multiple cash flow, things are a little bit more complicated. And that is a question that we need to answer with 2.3. So in question 2.3, if you have multiple cash flow, you have to set up the equation of value like these three. This is all equation value versus the equation of value at time t. T is anywhere between 0 and capital T. Um, the second equation is equation of value at time 0. The last one is equation of value at the expiration at the terminal time, capital T. And we have a couple examples just to illustrate the point. This question, we have 1,000 cash flow at time 0. Interest rate is 10%. Repay at 1 year. So at time 1, the cash flow is 600, and the repayment at time 2 is P. So we're going to try to find the terminal payment, the last payment. And so you can see I draw two timelines. One is a timeline for when you borrow the money. One is a timeline for you when you repay the money. The two timelines should have the same value at any given point. So if we set up a equation for time 2. So at time 2, the 1,000 is growing 2 time period. So 1,000 times 1.2 to the power 2. At time 2, the second time equation value, the second timeline, the 600 is growing by 1.1 times, and the p is a value at time 2, so there's no growth factor, no accumulation on p. These two timeline these two cash flows should have the same value at time 2, so that we set them equal and solve for P. Similarly, there are other examples in 2.3.2.5 that allows us to calculate different things. Like this question is calculating I. I is a unknown interest rate. So you solve, this is actually a degree 2 equation. Solve for I, you will have the interest rate, effective interest rate, annual interest rate. This is the example about solving this question with a BA2 plus calculator. One of the things that we can do with BA2 plus calculator is to identify the cash flow. So basically, this is all the key. You click on CF second clear work to clear the cash flow worksheet. You key in 5,000, enter. That way you set the cash flow 0, cash flow at time 0, as 5,000. A deposit of 5,000, that was the initial deposit. A year later is deposit 3,000. So a year later, cash flow 1 is 3,000. The other cash flow is 2,000 after that. So at time 2, the cash flow is 2,000. So your CF2 is negative, CF, oh, what was that? Where was the 2,000 cash flow? 5,000, 3,000, 2,000. Okay. Calculate the I. So this is actually two different questions. Right, so I think this cash flow timeline is more accurate. After 2,000, her deposit balance is 11,000. So what is this cash flow exactly? Same question, right? All right, so at time 2, after the 2,000 deposit, her account grow to the 11,000. Her balance is 11,000. Yes, so since the total balance is 11,000, right after we deposit 2,000, that means if you take out your money at time 2, you'll be taking out 9,000. And that's why the cash flow looks like a little bit weird here. So the cash flow at time 2, I'm setting at negative 9,000. That way, the total cash flow, the value at time 2 will be 0. Right? Because if you take out those 9,000 that was in your account before you put in the 2,000, you'll be entering the empty. Your account will be back to 0, and that's really the reason for that negative 9,000. So putting all these cash flow in, and you can calculate IRR, which is implied rate of return by the cash flow. And so that implied interest rate will be 7.47, exactly the same as what you would have from this equation. So this is really how to use the BA2 plus calculator. We do have to figure out exactly what was the cash flow at any given point. Um, so pay attention to that. It's a little bit quicker than what I can do with this one. I remember I have to use quadratic formula in order to solve the 1 plus I. So I solve 1 plus I, then I minus 1 to get the I. That's really how we solved it in class. And the rest of the question have similar example. Let me see if the internet is still working. So let me show you one example. That is the example that I assigned for today. The last example, question 7, is an example that has two cash flows. I copied it over here. Basically in homework 2.2, question 7, and that's this one. So what you have is you can try to identify information from the question. You loan 5,000 5,000 today, all right? So you can think of this as at time 0. And what's your cash flow? If you're giving your money to us, so you're loaning it. So your cash flow is actually negative 500. All right, and that's number one. And $575 to the same friend a year from now. So that means at t equal to 1 a year from now, I guess you can call that CF1. The cash flow is, again, you're giving it to your friend. So to you, the cash flow is negative. And then receive a payment for both loans. So you're receiving, obviously the total is larger than the total money that you bought, you loaned. So at cash flow, the cash flow too. And then all these you can enter into the BA2 plus calculator if you want to 1225. So that is a positive cash flow for you because you get your repayment. What is the possible effective rate of interest for this kind of transaction? And you can set up equation for any time spot. So I do recommend setting the equation. That's kind of my habit, setting the equation for t equal to 0. So for t equal to 0, you can set up the so-called equation of value. All right, and that is at time 0, the negative 500 is negative 500. T equal to 0 is t equal to 0. But the negative 575 is the value at time 1. The has a lower value at time 0. So the gotta be discounted. So they're gonna divide by 1 plus I being the interest to the power 1. And now the at time 2 is 1225. That's the value at time 2. But at time 2 value at time 0, it should have a lower value. So this got to be discounted by 1 plus I. I is the one we're trying to solve, the implied interest rate by the cash flow, and that got to have a power of 2, and this is equal to 0. So then the negative cash flow, total value of the total present value of the negative cash flow should equal to the total present value of the positive cash flow. That means if you move all these one to the other side, they'll be composite, right? They'll be equal to each other. So if you want to solve for this, I would recommend having let's say we have x is equal to 1 over the 1 plus I. Really, that's discount factor there. So this discount factor is our x value. So the 1225x to the power 2 is minus 575 times x minus 500 equal to 0. So kind of try to rewrite it into a degree 2 equation and solve for x. This you can solve with a quadratic formula. There will be 2 solutions, and we take the positive solution because the discount factor or the interest rate can only be positive value. So if it's negative, that will be wrong. So we take the positive value, and I get a solution that is x is equal to 0.9153. You can double check yourself, and that's the x value I get. So from this x value, you can solve for the I. And I is actually equal to 1 divided by x minus 1. And that is from the equation up there. You find it. If you solve for x, and you can solve for I, and that gives us the I value that is equal to 0.09252. And that's a short example on the question 7. The rest of them are similar to this. This one has a 2 cash flow on the timeline other than the present value. So think about it, try to solve it with a B2 plus calculator or solve it with an algebraic equation. I hope this provides some example when you were working on your homework questions. Please let me know if you got questions. I have to apologize about the internet problem that I had today. Hopefully it will work okay tomorrow.